We are doing number 1 of the 2015 AP Free Response. It discusses integrals. So first let's look at our textbook for some review. In Chapter 4, Section 4, the fundamental theorem of calculus is discussed in terms of integrals. We'll do 3 practice problems for this section, then go on to the problem. So for the first one, we have an integral from 0 to 1 of 2x dx. So we start off by integrating it, and we get 2x squared over 2 evaluated at 1 and 0. So if you plug in 1, you get 1. If you plug in 0, you get 0. So you get 1. So that's the final answer. And then the second one, we have determine the area of a region for this graph, and then the integral would be from 0 to 1, this whole area. And so the graph would be from 0 to 1 of x minus x squared dx. So then you would integrate it, and you get x squared over 2 minus x cubed over 3 evaluated at 1 and 0. And you get 1/2 minus 1/3. And then you just simplify, and you would get 1/6 is the answer. And then for the third problem, we have find the area of the region bounded by the graphs of the equations. We have y equals 3x squared plus 1. So we would integrate it, and it tells you x equals 0 and x equals 2. So it's from 0 to 2, 3x squared plus 1 dx. So the integration would be 3x cubed over 3 plus x evaluated at 2 and 0. So then you would get simplified x cubed plus x evaluated at 2 over 0 equals 8 plus 2, which is just 10.
Now we're going to do the AP question and put our practice to the test. So the question says the rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t equals 20 times sine of t squared over 35 cubic feet per hour, where t is measured in hours, and the time goes from 0 to 8 hours. The pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate of d of t equals negative 0.4 t to the third plus 0.4 t squared plus 0.96 t cubic feet per hour for the time 0 to 8 hours. There are 30 cubic feet of water in the pipe at t equals 0. So the first part, letter A, asks how many cubic feet of rainwater flow into the pipe during the 8-hour time interval. So it really just wants the integral from 0 to 8 of